So here are two questions that are from last group tutorial that we had. So number one and number two, they're just a review from last time. Now you have 6 root 3 minus 2 root 8 and 6 root 3 plus 2 root 8. Honestly, you don't have to FOIL this. Why? Because this sign and this sign are opposite, and this is the same as this, and this is the same as this. If that wasn't the case, yes, FOIL. But we're here, you know, when you get to grade 11 and 12, any shortcut that you could take it. So 6 root 3 times 6 root 3, that will be 36 root 9. And then you don't do the FOIL and you get stuff in the middle. You don't need to do that because the middle is going to cancel. Whenever it's negative plus here and these are two are the same as these two, always the middle cancels. So you get away by multiplying first by first and last by last. So when I multiply last by last, I get negative 4 root 64, which equals 36. Square root of 9 is 3. I'm not square root of 3. Some of you wrote square root of 9 is the same as square root of 3. That's not correct. Minus 4 and square root of 64 is 8. What does that give you? That gives you 36 times 3, that's 18, that's 3, 9, 108, minus 32. And you could imagine that's going to give me 76. So that's the first answer. How about here? Here, if this is squared, some students, they get really excited, really fast, say, hey, I'm going to square this and I'm going to square this. We say when something's squared, it means that thing is multiplied by itself. So what you have to do here, you have to write 2 root 12 minus 3 root 6 twice and FOIL it because it's multiplied by itself. So if you FOIL this into this, you're going to get 4 square root of 144. And then this into this, you're going to get minus 6 root 72. Now this into this, you're going to get again minus 6 root 72. And then last and last, you're going to get plus 9 root 36. Which gives me square root of 144 is 12. 12 times 4 is 48. Minus 6 root 72 minus 6 root 72 is minus 12 root 72. And 9 root 36, that's plus square root of 36 is 6 times 9 is 54. Doesn't finish there. Now 48 plus 54, so 4 plus 8 is 12. 1 is a remainder, so 6 plus 4 is 102. Is that right? 60 plus 108. Yeah. Minus 12 root 72. The root 72, you have to break that down into 36 times 2 because 36 is a perfect square, which will give me 102 minus square root of 36 is 6 times negative 12 is minus 72, and the root 2 stays under the square root. Yeah, sorry, I forgot to write the 2 there. So these first two questions are from the questions we had from last week. Okay. Now, this is the new stuff here. We teach you, the first thing we teach you about fraction is reducing. You always have to keep that in mind when you're doing fractions. So here, reducing. 4 goes into itself once. It goes into 12 3 times. Root 3 goes into itself root 1 time. And root 12 will go into itself root 4 times. So I divided root 3 by root 3 and I divided root 12 by root 3. I get root 4. We have 1 on the bottom, so you don't have to write it. And you have 3 root 4, which is the same as 3 times 2, which gives you 6. Here again, think reducing. 16 and 5 you cannot reduce, but root 10 and root 50 could be reduced, and you get root 5 on top. So the final answer here is going to be 16 root 5 over negative 5. I always like to write the negative on top, so I'm just going to write negative 16 root 5 over 5. Can we reduce root 5 with 5? No, we can't. because that's a root and that's a whole, no, that's a rational number. You cannot do that. You only could reduce roots with roots, and you cannot reduce roots with rational numbers. Okay. This here, the negative cancels the negative. 8 goes into itself once, goes into 45 times. So I'm dividing top and bottom by 25, because both of them, 25 goes into both of them. So 25 goes into root 50, root 2 times. And root 25 goes into root 125, root 5 times. Now we have answer 5 root 2 over root 5. And this here is going to bring us to the new lesson, the last question here, which is rationalizing denominators. Okay. So rationalizing denominators. So what's rationalizing denominators mean? We don't like having a square root on the bottom. And we want to get rid of the square root on the bottom. How do we get rid of the square root on the bottom? If I multiply this fraction by root 5 over root 5, then we're going to get 5 root 10 on top, because 5 root 2 times root 5, you get 5 root 10. And on the bottom, I get root 25. And root 25 is just 5. Also know when you multiply a root by itself, you just lose the root and you get the 5. If you want to go through the step writing root 25 first and then changing it to 5, that's fine. But when you do that so many times, and I don't know why students sometimes are scared to do it. When you do this all the time and you get root 25 and you know root 25 is 5, you should induce, as a student, you should induce, oh, so every time I multiply a root by itself, I should get just 5. I don't even have to go through that intermediate step. That's what we want you to induce from doing this. When you do it so many times, you should say, oh, okay, I don't have to write root 25 in the middle and stuff like that. Okay. So now let's go to the next thing. So in this case here, you could divide root 50 by root 2. And what you're going to get, you're going to get root 25. Minus root 30 divided by root 2, you get root 15. Root 25 is 5. Root 15, you cannot find the root of that. You cannot change it to mixed radical because there's no perfect square that goes into root 15. So now some of you think, since we could do this, then we could maybe go root 3 goes into itself once, goes into root 27, or root 9 times, and then it goes on root 3, root 1 time. And so we have 1 over root 9, which is 3, minus root 1, which is 1, and that would give me 1/2. Okay. So some of you wrote this answer, okay? Now,
wait, Mr. Sami?
yeah.
Sorry to interrupt, but like, for the 50 and the 30, did you do 50 divided by 2 and 30 divided by 2? I thought you would cross it out or something like that.
Yeah. So that's what we did. It's reducing is the same as canceling, but you have to reduce both of these with this, not just one of them.
Oh, okay, thank you.
Let's say this was root 7 there. Instead of root 30, then you cannot reduce anymore. You cannot reduce this with that. Either both or none. So you either reduce both of them or you cannot reduce at all. So as I said, if it was root 7, then you won't be able to do anything. You just have to leave it like that. Okay. So now, can we do this? Let's look at it. Okay. So if we have 3, like we're just going to take normal numbers. Okay. 3 over, let's say 12 minus 6. Okay. So if we do that, then we're going to get 12 minus 6 is 6, isn't it? And we're going to get 1/2 as an answer. So this is a scenario that's comparable to this. Okay. Now, let's say what we did here, can we do the same thing instead of doing this? Because we know definitely an order of operations like this, we should get 1/2 as an answer. Let's say I decided to say, okay, if I could reduce this with this and this with this, then I'm gonna do it. So I go 3 goes into self once, goes into 12 4 times, goes into 6 2 times. So that's 1 over 4 minus 2, which is 1/2. Can we try it again and make sure it works? So let's say we had a 5 and we have 45 minus 15. So we know that is going to give us 5 on top, and 45 minus 15 give us 30, which give us 1/6. Okay. Now, if we reduce, 5 goes into itself once, it goes into 45 9 times, and 5 goes into itself once, it goes into 15 3 times. So that gives us 1 over 9 minus 3, which is 1 over 6. So that works. We could do it. Yeah, so we could do it. Since when we did this, when we did the order of operations, we got 1/2, and then when we did the reducing, we got 1/2, and here the same thing, then definitely we're able to do this. And this answer will be 1 over 3 minus 1, which is 1/2. Okay. Let's do it another way. You know, the best thing about math, it's not always one way that you could do things, you know. So let's do it another way, just for fun. So let's leave this root 3 as is. Let us change root 27 to root 9 times 3 minus root 3. And if you want to become a good mathematician, always try different things and arrive to the same answer, because then you can start making your own conclusions and, you know. Now, let's continue with this. So root 3, square root of 9 is 3. So that's 3 root 3 minus root 3. Okay. Now, that's going to be root 3. Because both terms have root 3, so I'm going to take root 3 out as the greatest common factor. I'm going to get 3 minus 1. Because root 3 is the greatest common factor. See, if I multiply root 3 into 3, I get 3 root 3. If I multiply root 3 into the 1, I get root 3. So I could take it out as the greatest common factor. Now, this and this will reduce, and I'll get 1 on top. So that's 1 over 3 minus 1, which is 1/2, which is exactly what we got in last time. Okay, so there's so many ways to do things. So let me go to the next concept. So with these two here, the first one and the second one, I'm going to do them, and then I'm going to let you do number 3 and 4. But you know what? I'm going to start off with number 2 because it's a little bit easier than this one. So can we reduce anything? No, we can't. 3 and 2, we cannot reduce them. But look, root 3 and root 6, we could reduce them. So I'm going to show you 2 ways. Like you could not reduce them and go, okay, I'm going to rationalize the denominator. And any of you who did this in school, a lot of teachers say when you're rationalizing the denominator, you multiply the top and the bottom by the denominator. So you multiply both top and bottom by 3 root 6. 3 root 6. And I kind of get, you know, bothered with this, like why you have to multiply by 3 root 6. It doesn't say that you have to multiply by the whole bottom. Why are you multiplying by the whole bottom? If you want to rationalize the denominator, you don't want any square roots on the bottom, you don't need to multiply by the whole bottom. All you need to do is just multiply by root 6 and root 6. And you'll see some of you who haven't gotten to this section yet, most teachers will say multiply top and bottom by 3 root 6, 3 root 6. Just creating more extra steps for yourself because you have to reduce a lot later, you know. But this is what we're supposed to do. Just multiply by the radical only. Don't multiply by the 3. Even though lots of teachers say multiply by 3 root 6. No, that's wrong. It's not wrong, but it's just, it's why, you know. It's, yeah. So if multiply top and bottom by root 6, 2 root 3 times root 6 will give you 2 root 18. And the bottom will give you 2 times root 6 times root 6 is root 36. But also instead of writing root 36, can we write root 6? Remember what I said to you earlier? I said, when you multiply a root by itself, ignore that middle step and just go, that's 6, because it's root 36, but root 36 is 6. So you could write that like this right away. That's a 3, that's not a 2. 3 root 6 times root 6 is going to be 3, and root 6 times root 6 is 6. Okay. Now, here, 3 times 6 is 18. So if you want to, you go just 2 root 18 over 18. And 2 goes into itself, 1 goes into 18, 9 times. But also you could change the root 18. Okay, I'm just going to move that thing to the side here and maybe try to finish it right here. So we could take the root 18 and make it root 9 times 2 over 9, which gives me root 9 is 3, and the root 2 stays in there, over 9, which reduces, 3 goes into itself once, it goes into 9 3 times, so it's root 2 over 3 is your final answer. Okay. Now that's the long way of doing it. But if you want to be smart about this, you say, you know what? I'm not going to do all of this because it's a lot of work. And Sami always said, if you could reduce first. Root 3 goes into itself once, it goes into root 6, root 2 times. Now what we have 2 over 3 root 2. Multiply top and bottom by root 2 over root 2 to rationalize the denominator. You're going to get 2 root 2 over 3, and root 2 times root 2 is root 4, but that's 2, so you could take that shortcut. Okay. And since you see a 2 here and a 2 there, instead of going 3 times 2 is 6, and then 2 root 2 over 6 and reduce later, I could just cancel that 2 with that 2 right away, and then I'm going to get root 2 over 3, which is this and this. Both of them are correct, but this is long. Reduce always in math. When we do in math, we always tell our students, simplify first and then go to the next step. Anyways, we'll move on. So that's good. Now here, now you might argue and say, you know, Sami said you only multiply by the root. I'm just going to multiply this by root 3 over root 3. Let's say that's what you thought. Okay, if you do that, then 3 times root 3 on top, you're going to get 3, root 3. And on the bottom, root 3 times root 3 is root 9, which is 3. And minus root 3 times 1, which is root 3. Did you rationalize the denominator? No, you didn't. You still have a radical on the bottom. You still have a square root on the bottom. And that's rationalizing the denominators means we don't want square roots on the bottom. So that's the wrong step to do. You could do that here because there's no minus sign in between the 3 and the root 6. These two things are multiplied. You could do that. Just multiply top and bottom by root 6 over root 6. But here, it's a new word that you're going to learn. And it's basically multiplying by the conjugate. So you're going to multiply by the conjugate. So what's the conjugate? The conjugate is, you see this bottom here, which is root 3 minus 1. You change the sign in the middle and you multiply by the same thing, except you change the sign in the middle. And that has something to do with the difference of 2 squares, you know. If you do that, then you're not going to have radicals on the bottom anymore. You're not going to have square roots on the bottom anymore. So let's just multiply the top. 3 times root 3 is 3 root 3. And 3 times 1, that's plus 1 root 3. Or 3 times 1, just 3, sorry. And here, you got to FOIL this. But you remember what I told you? If you have the same thing here and the same thing here with the signs being opposite, you could get away by just multiplying the first by the first, and you get 3. Root 3 times root 3 is 9, root 9, and root 9 is 3. And then you go negative 1 times positive 1, you get minus 1. If you want to remember anything today, okay, remember when you multiply two things that are the same except with the sign in the middle, you don't have to FOIL. You don't have to have the 4 terms and then cancel the middle anymore. You could get away by multiplying the first by the first and then the last by the last. That's only if you have these being the same and the signs are opposite. But let's say the sign was a minus, then you cannot do that. You have to FOIL it. Only if the sign is opposite. So if you want to come out of with anything today in today's session, just remember that. All right. Now this will give me 3 root 3 plus 3, and 3 minus 1 on the bottom gives you 2. And that's as far as you get. This here and this are exactly the same, by the way. Some of you are looking at this and say, well, would this equal this? Yes. If you go to your calculator, find out what root 3 minus 1 is, and then you go 3 divided by that, record it, and then go 3 root 3 plus 3, enter, and then divide it by 2, and record it, and you'll find the decimal that you answer that you get. Both of these will be the same. Okay. Now, I'm going to leave you with number 3 and number 4. Try to do them yourself and then send me your answer. Taha, we still haven't heard back from you, buddy. So as we said, the title in here is rationalizing rationalize. I have to get my, look at, I'm erasing right here, and the whole question on the bottom disappeared. So Zoom, this is Zoom stuff. What's going on here? It's a freaky eraser. I think it was 7 root 2 over 5, wasn't it? Root 5, sorry. Was the question like that?
No, it was 7 over 2 square root 5.
Okay. 7 over 2 root 5. So if you want to, in rationalizing denominators, so let me just, so rationalize the denominator. That's what this topic is all about. So the topic is rationalize the denominator. Now, rationalizing the denominator is to get rid of the square root on the bottom. To get rid of the square root on the bottom, all you need to do to this equation here, just multiply the top by root 5 and the bottom by root 5. Why? Because we know when we multiply this root 5 by root 5, we're going to have 5, or root 25, which is 5. So we don't have roots on the bottom anymore. Okay. So here, what we'll get 7 root 5 over the 2, and root 5 times root 5 is just 5, which gives me 7 root 5 over 10, and that's your answer for the first one. All right, so here in this, it's a different story altogether, because in here we have to multiply, and the word was that we did in here, we called it the conjugate. Why? Because it's root 3 minus 1, and it's not one thing together, it's 2 terms. So here we have to do the same thing. We have to multiply both sides by the conjugate. So here, the conjugate, what's the conjugate? What should I write here? The conjugate is the same thing. See here, the conjugate is the same thing, except it's with the opposite sign. So that's the conjugate. You're not only going to use the conjugate in square roots and radicals, you're going to use it in trigonometry. You're going to use it when you do calculus and you're doing derivatives. So remember that word conjugate means you write the same thing on the bottom, which is 2 root 3 and root 2, except you change the sign to plus. And if this is a plus, then you write a minus here. That's what the conjugate is. So which means you have to multiply this by this. And whatever you do to the bottom, you have to do to the top, always. Why do we have to do that? Because this divided by itself is 1, and you're allowed to multiply it by 1. And it doesn't change the equation. It changes the look, but it doesn't change the quantity. Okay. Or the value. Now, on top, I have 4 root 3 times root 3 is going to give me 8 root 9 or 3. Because remember I said root 3 times root 3, it just gives you 3. Plus 4 root 3 times root 2 is 4 root 6. Now, what did they say about this when I was talking about if these two are the same and the sign is different? What did they say? What we supposed to do? Should I FOIL the whole thing, or is there a shortcut that I could take? Can anybody tell me? Guys, I was emphasizing this. I was saying, like, take this home with you. Like when you multiply something by its conjugate, you know, if we have x minus y times x plus y, instead of going, okay, I multiply x times x, I get x squared. I multiply x times y, I get plus xy. I multiply negative y times x minus xy. I multiply negative y times y, we get negative y squared. And this will cancel, and we end up with x squared minus y squared. Because these two things are the same with the opposite sign, the difference of squares, we could just take a shortcut, multiply first by first and last by last, and I don't have to go through this step. That's what I said, take home with you. Like whenever you're multiplying something by itself, except the sign in the middle is opposite, then you could take that shortcut. So you go 2 root 3 times 2 root 3, which is 4 times 3, because root 3 times root 3 is 9. Square root of 9 is 3. So take that shortcut and don't write root 9 and then just go 3 right away. Minus root 2 times root 2 is 2. So negative root 2 times positive root 2 is minus 2. 8, sorry, that's 24. Minus 4 root 6 all over 12 minus 2 is 10. Now, when you get here, if you leave the answer like this, you lose half a mark from the answer. Because why? Because we have 24, we have 4, we have 10. All of them reduced by 2, so I should reduce this by 2, and I should get 12 minus 2 root 6 all over 5. Any questions? Class is finished. Thank you for attending, guys. I will see you next Tuesday, same time. Bye-bye.